One main application of exponents is when something is growing or decaying, an exponential rate. The main equation is this. Now, there are three important locations that I want to talk about. A, meaning the location in front of your base, is going to be the initial amount. A for amount. B is what is directly underneath. It's the base of the exponent. So B is the base, and X is the exponent. Now, your base is going to be your multiplier. So if something is doubled, that's 2. If something is tripled, it's 3. If something is halved, it's half. Now, most frequently, you're not going to get something in those nice terms, 2, 3, or half. You're going to get something with what is an R. So we need a different equation, which is quite similar. Now notice the B was replaced with 1 plus or minus R. We're getting a little complicated with plus or minus, but bear with me here. R is referred to as a rate of growth when R is positive, or decay when R is negative. And R can be expressed as a decimal, but more frequently as a percentage. Now we need to recall how to convert from a decimal or percentage to go back and forth. We need to be fluent in both. So the way I remember is a percentage is based off of 100, based off of 100%. Now 100 has 2 zeros, and so we're going to move the decimal 2 spaces. 2 spaces one direction. Well, if we're going from decimal to percent, we're moving that way. If we're moving from percent to decimal, we're moving that way. And I wrote these in alphabetical order. So for instance, if it was 0.85, that would be, move it twice that way, 85%. If, however, I was talking about 2.75%, I would move the decimal 2 the other way. And because there's an open space here, it would be 0.0275 as a decimal. Now I want to point out that this is either positive or negative, depending on which it is. So let's see an example. All right. What is the initial amount here? Well, A is 3.2. That's the initial amount. My base is 0.64. But recall that my base is rewritten as this. So I can have a third equation here. My base is equal to 1 plus or minus R. So I'm going to say that 0.64 is equal to 1 R. And we see that the value is less than 1, so it's going to be minus. So we can solve for R by minus 1. I get negative 0.36 equals negative R. I have to divide by negative 1. R is equal to 0.36, which is in decimal form. More frequently, it's going to say as a percentage. So my R is going to be, move it over twice, 36% decay. Now it's important to notice decay because when I say 36%, you didn't know that it was minus, right? If my only answer is A and R, I don't know if that's plus 36% or minus 36%. So because this was a minus and because this was less than 1, I need to say decay. So these are my 2 answers. This is the algebra way of doing it. There's another way of doing it too. What is the difference from 100%? Well, we see that this is obviously lower than 100%. This is 64%. So what's the difference? We would just subtract them. And it is lower by 36%. So 36% decay rate. All right. 2 is similar. A is 0.72. That's just its value. B is going to be 4.5. Now that is more than 1, right? My B is 1 more with R or less than R. So I'm going to say that 4.5 is equal to 1 plus R. Let's solve for R, minus 1. R is equal to 3.5. Now again, that is as a decimal. I don't want a decimal, I want a percentage. So I'm going to take my 3.5 and I'm going to move it from decimal to percent. I'm moving to the right. So it's 1, 2. And since there's an open space, it is there. Now this is odd, but this happens. My R is equal to 350% growth. Here are my two values. And for this last one, you can try it on your own. You can pause here, but I'll do it. I'll give you the answer. A is equal to 300. Base is equal to 0.4. All right, my 0.4 is equal to 1. Is it plus or minus? Well, it's definitely going to be minus because it's lower. So solve again. Negative R is equal to negative 0.6. Divide by negative 1, divide by negative 1. R is equal to 0.6. R as a percentage, move it over twice. As I move it over twice, there's a space that's missing. It needs to be 0. 60% decrease, decay. Now that is just the pure algebra. When we get into applications, here is my formula again. Now, this is the formula we give you. We also need to recall as a little thought bubble that B is equal to 1 plus or minus R. All right, so profit tells me I'm going to be dealing with a positive R. So I'm starting with $5,000 and it's increasing by 15% each year. Okay, so A is equal to 5,000, R is equal to 15. I'm going to write percent because I don't want to get it confused. Which one did they give me? They gave me percentage. Now my formula can only handle a decimal. I'm going to write that. Formula only decimals. That is key. So I'm going to have to do this and make sure it's a decimal. Now I'm going to need to convert this to a decimal if I'm going to make an equation out of it. So I'm going to, the implied location of the decimal is there if it's a whole number. So I'm going to move it twice to the left, 0.15. So my equation is y is equal to 5,000 as my starting, 0.15 as my, If R is 0.15, my base is 1 increase plus 0.15 x. Now I wouldn't write that. That's not simplified. So y is equal to 5,000, 1.15 x. Now on the next page, we're going to have to go backwards. So if I see this, just like above, am I able to notice? Well, oh yeah, if my basic base is 1, this is 0.15 more, right? So 15% increase. College enrollment of this starting amount, A is equal to 41,000, decreases, that's a negative R, by 1.4 each year. So my R is 1.4%. Now I'm going to have to change that to a decimal if I'm going to be working with an equation. So I'm going to move it from percentage to decimal. I'm moving to the left. 1, 2. 0.014. Do you see it originally was between the 1 and 4 and it moved 2? So my equation is 41,000, 1 minus 0.014 to the x, which is 0.986 raised to the x. Now you can see when you compare this equation to this equation, this 15% is very intuitive. It's more than 1 by 0.15, less than 1. We as humans are a little, it's not very intuitive to do subtraction the same way it is to do addition. So we have to notice that if we are going to pull out the rate and go backwards, we're going to have to do this conversion, this subtraction, and solve. We can see it's definitely less than, and it's less than by a very small amount. This is like 0.9. 0.9 is very close to 1.0. Right, one more example. The stock valued at 24, okay, that's my starting. Increases, that's a positive R, by 2.3%. Change to decimal is 0.023. So my y is equal to 24, 1 plus 0.023 x. 1.023x is my equation. And you can see the value of this would be, once I have this equation, can I go far into the future? Can I plug in a value each year? Maybe I want to invest for 15 years. What is the value going to be at that point?